All right, so the purpose of this video is just to remind you really of something that you certainly have seen before, whether it be in Alex or in a past course that involved Trig, or I guess if you haven't seen it before, now you're going to see it for the first time. But the big idea here is we have trig functions. Those are like our sine, cosine, tangent, things like that. And the trig functions, you always put in an angle and you get out a ratio. Like you know what the sine ratio is, opposite over hypotenuse. And so when you put in whatever angle you do, you get out whatever ratio corresponds. So an example of this would be like sine of pi over 2. Note what we're putting into our function is an angle, and what's coming out is a ratio. But that's, well, the thing to think about is here, while the original sine function takes you from an angle to a ratio, you could have the corresponding inverse function, which takes you from a ratio to an angle. Because here's the deal, if you have a ratio of square root 2 over 2, there is some angle that corresponds to that. In particular, the angle which corresponds to that the sine inverse function takes you to is the pi over 4 angle, right? So here, the sine inverse function, you're putting in a ratio and you're getting out an angle. So here is pi over 4, what, a 45-degree angle. If you remember in your 45, 45, 90 triangle, you have sides of 1 and square root 2, which would yield this ratio. But the long story short is, with the original sine function, you put in an angle, it gives you back a ratio. And with the inverse sine function, that reverses. You put in a ratio and get out an angle. And just to see this from the full totality, I mean, look, sine is a function that puts in an angle, get out a ratio. Tangent works the same way, right? Put in an angle of pi, get out the corresponding ratio. But you could play the game in reverse with the tangent function, which is say, what if negative square root 3 over 1 was your ratio? You may recall, I suppose, that, whoops, let's draw this slightly better. You may recall that if you have an angle with a side ratio of minus square root 3 over 1, this is your 30, 60, 90 triangle, and this angle here is your 60-degree angle. So when you have a tangent ratio opposite over adjacent of minus square root 3, this results in an angle of minus pi over 3, a negative 60-degree angle. But the long story short is here, the original function, you put in an angle, you get out a ratio. The inverse function, you put in a ratio, get out an angle. And now, all of this is really just pre-calculus function stuff. How does this relate to calculus? Well, every traditional trig function, sine, cosine, tangent, cotangent, cosecant, secant, we know how to take their derivatives. So everybody over here, we know how to take the derivative. We've worked hard to find formulas that allow us to find the slopes of the tangent lines for functions such as these. But now the question is, well, since every trig function has its corresponding inverse function, do these functions have derivatives as well? The answer, as you might suspect, is yes. And then I guess the question is, what are the derivatives to these functions? Can we find them? And then can we have those at our disposal in terms of formulas that would allow us to then find the slopes of tangent lines along these functions?